Assalamu alaikum. Today my topic is drones on agricultural sector. Industrial chemistry. Abstract. This research study examines the innovation in technology related to drone, investigating its multiple applications, social effects, and the changes in its development with its use. This research paper highlights the pivotal role of drones in overcoming obstacles such as search, rescue, operation, natural disaster management, and providing effective solution and nutrition to crops as a comprehensive approach to agronomic management. Digital precision agriculture DPA uses state-of-the-art technologies such as automation, sensor data processing to increase the crop yield, weed monitoring, and lessen the environmental impacts. Unmanned aerial vehicles UAV are one of the TPA enabling technologies that have attracted a lot of interest and seen a rapid commercial expansion. Advanced agricultural drones are the result of development in robotics, electronics, artificial intelligence, and control systems. Furthermore, UAVs may now carry out numerous tasks at once without sacrificing flight autonomy because to sensor miniaturization and nanotechnology developments. This paper provides an overview of UAV types, construction structures, and diverse agriculture applications throughout 2022. Introduction. The term drone was first used in 1946. Drones are also known as remotely piloted aircraft RPVs. They have been proved as a vital and essential tools in detecting long-term obstacles. Mainly, drones are not only used in military but also various industries, including agriculture, infrastructure monitoring, environmental monitoring, photography, cinematography, and disaster management. They also deliver the new and effective remedies for problems we face in agriculture sector. This evolution has been stimulated by many advancements in technology, resulting in best and efficiency in drone operations. Because of the population's rapid growth, ensuring food security is becoming increasingly difficult. The Food and Agriculture Organization's FAO of the United Nations reports that over 815 million people suffer from chronic hunger. On the other hand, the basic resources for agriculture production, such as land and water, are becoming scarcer every day. In a study, drawn in 2018 has been revealed that 9.2% of people on earth had extreme degrees of food availability problems. The 21st century has seen a remarkable advancement in precision agriculture technologies. Even nevertheless, the great majority of farmers in the United States don't use precision. In recent time, agriculture has undergone various changes due to the incorporation of drone technology. Application of drone in agriculture has drawn more attention recently as a potentially effective way to enhance conventional farming methods. Unmanned aerial vehicles (UAVs), sometimes referred to as drones, have a number of benefits over conventional techniques. Drones have the ability to improve crop efficiency and productivity in agriculture. The use of the drones in agriculture is anticipated to grow rapidly over the coming years due to growing and accessibility. Drones can also be used to accurately apply fertilizers and pesticides to the crops. One of the most significant advantages of using drone in agriculture is the ability to provide real-time data on crop condition with the help of the sensors and cameras mounted on drones. Drones collect data on the factors such as soil moisture content, nutrient levels, temperature, which can help farmers make more informed decisions about irrigation and fertilization. Drones can provide high resolution images of crops in addition to real time data. High resolution imagery can also be used to analyze crop growth patterns, identify areas of the field with lower yield, enabling farmers to adjust their practices and improve overall crop productivity. This can lead to more efficient use of the resources. Farmers can cover more ground in less time with the aid of drones, which lowers the demand for manual labor and boosts output. This can lead to improved efficient use of resources such as water and fertilizer and ultimately higher yields. Overall, the use of drones in agriculture can help farmers save time and money while improving the quality and quantity of the crops. While the use of the drones in agriculture holds great potential, it helps in insect and pest management, fertilization, irrigation manual, snowing and crop health mapping and monitoring, yield forecasting, harvesting and post-harvest stages. Precision agriculture. Precision agriculture is a strategy which will be used to advance our technology to improve crop and soil and many other issues, that is improve crop production, soil monitoring, weed monitoring, insect and pathogen monitoring, etc. The technology used in drones for the agriculture purposes. Drones with UV sensors can help farmers in the detection of plant health, insect infestation, illness, and crop stress in agriculture that might not be apparent in normal lightning circumstances. Helicopters and fixed aircraft have dominated the unmanned area vehicle UAV market in the last 10 years. The focus has switched to multicopters, which currently account for about 50% of the available UAV model. Drone technology using tiny sensors like accelerometers, magnetometers, gyros, pressure sensors, etc. Furthermore, GPS models and strong CPUs, digital radio range, drone technology are also getting better. Better drone technology for remote field monitoring is another result of this. Additionally, drone technology advances due to the ongoing development of the usage of semi-controlled drones. The use artificial intelligence in the center of it was the only factor considered while choosing a semi-controlled drone. AI systems are also using in this. Additionally, drone technology advances due to the ongoing development order to increase the yields of crop monitoring. This study examines over 30 articles about the use of the drones for agriculture, crop monitoring, and the investigation of various vegetation indices. The adoption of drones for non-invasive phenotyping is gaining popularity due to their capacity to capture high-resolution images with both temporal and spatial precision. The authors argue that phenotyping is a widely used process to select plants or seeds with a favorable phenotype, capable of conferring advantageous properties and better resistance to pests and disease. Here is the image about the drones monitoring the crop health and their conditions. Farmers keep an eye on their crops every day to look for any possible dangers like pest infestation, sluggish development, etc. Crop growth has been tracked using color and infrared photographs taken by the various platforms for over 50 years. The choice of sensors to be utilized in conjunction with drones is crucial. Drones have been regularly improved by the researchers who have created task-specific drones, but in 2011 the UAV system made its debut in the agriculture industry. 2010 Raymond Hunt created a digital color infrared camera system for monitoring wheat fields. Then in 2012, Jacob Premisria created the VIP Taro unmanned area vehicle, which this was used to vineyard management specific to a given place. It was an autonomous helicopter equipped with the multispectral camera that could operate at certain locations. Then in 2015, Hassan Asfahani proposed a remote sensing technology in drones named Aggie Air for agricultural application. It had capability of capturing images in red, green, blue, RGB, near infrared and thermal spectrum. It provides high quality multispectral image data for crop health monitoring for crop tissue nitrogen, chlorophyll and soil moisture. In 2016, Centestiban investigated the water status of grapevine plantings. The crop water stress index was used to analyze the health of the crops. It demonstrated the importance of SWSI based water status measurement for crop health analysis. When the manually gathered data and the data obtained through image processing was compared, a little discrepancy was discovered. Then in 2017, a basic multispectral image system for UAV-based agriculture application was proposed by Paradis. A lower order system was created that uses multiple cameras to capture multispectral images. It successfully synchronized with the data collecting system and flying controller. In 2018, Arnav Kumar Saha proposed the drone system for the real-time crop data IoT-based drone system. Real-time data analysis was done using smart sensors and module. Raspberry Pi 3B module were used to combine the suggested solution with drone. Machine learning method was used to teach system to forecast the health of the crops. Then in 2019, Jack proposed the idea of the visible atmospherically resistant index for estimating soil parameters. After predicting the pH of the soil in the pineapple crop field and comparing the results with pH data for laboratory testing and the comparisons, R squared value were roughly 51%. 2020, Suetel have proposed an automatic yellow rust disease monitoring. The system using UAV multispectral camera has been used for the data collection. Some important outcomes have been attractive for the research drawn in crop monitoring during the last decade. In the recent year, many crop condition monitoring methods were developed based on remote sensing data. Crop condition monitoring indices such as normalized different vegetation index and the leaf area index are the foundation of the data monitoring techniques. A continuous improvement in machine learning, computer vision, AI technologies is making it more accurate and user friendly and also the eco friendly. IoT based technology collects crop data using several sensor types and then uses a simulation model to analyze the data. Then weed monitoring. According to several writers, weeds are the main source of the yield loss in agriculture output and making up nearly one third of the total. The next target losses, largest losses, are caused by the plant disease and animal pest infestation because of the distinct mechanism of environmental adaptations. Important competitive abilities with wild species, especially weeds, are resilient to environmental stresses than cultivated species. Traditional chemical and mechanical pest control technologies have several shortcomings in terms of economy, environmental sustainability, and operational performances. Here is the image of the drones monitoring the weed health and conditions. The red one denotes the weeds which will have to be removed, and the green are the fresh, healthy weeds that have to be that we have to keep so that it will grow into a healthy plant. Early identification is crucial for preventing and limiting the growth of the pest. Artificial neural network based research is currently playing a significant role in this context, using a highly dependable detection method and technologies to accurately distinguish between crop species and weed is a crucial component of putting automated weed management system into place. Here is a tree diagram of how the UAV system in drones monitor the weeds. Site specific weed management and selective treatment. In selective treatment, weed mapping, then selective treatment, mechanical soil tillage, herbicide suppress, that is economical and agro ecological implications, weed resistance, production cost, biodiversity, and environmental impact. Insect and pathogen monitoring. It is common knowledge that crop damaging insects can cause havoc and organize significant global lower food grain production. Food and Agriculture Organization had that illness and pests result in losses of several 37%. Recent development in multispectral imaging technology with UAVs has again have opened up new possibilities for crop monitoring and management even for small scale agriculture system. One of the best methods for keeping eye on, controlling and conducting surveillance of pests is the use of the unmanned aerial vehicle. Examination of pathogen caused illness appears to be a regular practice. Furthermore, research conducted by 6971 had demonstrated that imaging is an objective method that differs from the visual evaluations and may be included into automated system which will significantly reduce efforts. Additionally, pathogens have major impact on the 700 to 1000 nanometer range of near infrared wavelengths. Necrotrophic disease, which specifically result in plant cell necrosis and changes in water content indicated by increased reflectance in specific water absorbance bands in the short-wave infrared at 1400 to 1900 nanometer. Pathogens also have a significant influence on near infrared wavelength extending from 700 to 1000 nanometer. Pesticide spraying. Research and advancements in UAV based pesticide spraying system are covered in this section. In many regions of the world, pesticides are still applied, primarily using conventional method. The most widely used instrument for the traditional pesticide application is the manual mechanical spraying. Humans are impacted by the manual pesticide application, which can result in conditions like cancer, hypersensitivity, asthma, and other ailments. Conventional methods also have a number of other drawbacks, including the use of additional chemicals, a shortage of farm labor, lower spray consistency, pollution of the environment, and a smaller coverage area. The use of the coverage capabilities and the ease and speed of the spraying processes. These days, drones may carry up to 40 liters of the insecticide. Insecticides fly along pre-planned paths to spray fields as needed. Estimating the payload is the first step in designing a drone. For Supreme has chosen Yamamoto Co. Limited, Shizuoka, Japan created the first unmanned aerial vehicle UAV for the application of pesticides in 1983. This helicopter controllability and stability made it unsuitable for field use. This UAV system was controlled by a controller based on pulse width modulation, that is PWM. When used in vector control application, this technology produced satisfactory results. A PWM regulator based remotely operated pre-programmed helicopter for pesticide spraying in agriculture field were proposed by Zoo in 2010. Although the device was managed remotely and the telemetry system that transmitted the signals was imprecise. In 2017, Bruno's presented an adaptive control strategy for pesticide spraying with UAVs in dynamic situations. When the weather changed, static configuration was infected. The two components of the environmental system, software system, were collector and actuating, and second is the optimization core of OPTIC. After reviewing the weather, Call Act revised the restriction for road changes. In 2017, a multi-UAV system based on genetic algorithm was presented by Helio for the optimization of pesticide spraying duties. These included the temperature of the surrounding area and the quality of the pesticides to be applied. In 2017, a drone called Freer was created by Sporty for the field application requiring uniform spraying. In 2018, a more accessible to farmer agriculture technology was created by B. Balaji. A helicopter was created. Crop monitoring application employed Python programming to detect the weeds and disease. In 2019, Shenman designed a UAV integrated variable spray system that was based upon artificial neural network. A program was written in Kale software for applying the pesticide as per the requirement. A drone called Aerodrome was created by Kislaya Anand and Gotham in 2019 for chemical spraying and field monitoring. A remote control station was used to regulate the pump speed. This pumping range was 0.10 to 0.22 liters per minute. An octocopter was the lighter spraying station was created in 2020. Both the drone flying controllers and the spraying system have been significantly advanced in recent years. Soil monitoring. The soil, a matrix of the organic inorganic material serves as the growing material for the field crop. Any management system must have its elements must be carefully examined before it can be created. Soil monitoring implies a variety of techniques that fall into three categories: laboratory research and soil sampling, proximate sensor use, and remote sensor use. Soil sampling is costly, time consuming, and destructive method of research that is often unsuitable for studying dynamic processes. The most widely used remote sensor for monitoring soil parameters are satellites or drones. The parameter that are most commonly researched are determined by a review of scientific literature: soil moisture, soil salinity, gas detection, organic matter. Soil moisture. Soil moisture content SMC is an important physical element that influences the nutrient availability, hydrological processing, and soil deterioration and structure of the soil aggregates. Advancing in hyperspectral technology in remote sensing have made it easier and more efficient to acquire SMC data across larger territories. They were able to determine the moisture content of the surface soil with accuracy by combining vegetation covering with the brightness of visible UAV photographs. Remote sensing techniques offer a variety of domains for estimating soil moisture. By creating new opportunity for spatial and temporal resolution, drone use the enhances the outcomes of traditional remote sensing methods. Soil salinity. Soil salinity means how much a salt quantity is present in any soil. It happens because when excess water from factories enters into the soil, the soil salinization is a significant ecological danger that results in soil degradation, ecological decline, and the loss of the agricultural land. Currently, estimates based on canopy temperature or the utilization or reworking of the agriculture vegetation indices in the soil are the main scientific references. The final new research area in the subject that we mentioned is the study of of 2007 who proposed a methodology to quantify soil salinity through the combined analysis, gas detection, monitoring the effects of agronomic practices, determine the best management strategies can both be accomplished with the help of measuring gases in soil used for agriculture crop. In order to better grasp the potential of ethylene surveying in an apple orchard, a 2019 study investigated the combination of miniature sensor installed in UAVs. More promising outcomes were attained in who provided an accurate description of the design and flight test of a UAV fitted with carbon dioxide sensor and onboard camera. Though this is undoubtedly one of the most intriguing areas to research in the future, soil organic matter is the one of the most important markers. Soil fertility is soil organic carbon, mainly the organic matter that is present in soil are carbon dioxide, methane, etc. It can be estimated using a variety of techniques and technology. Remote sensing techniques have advanced quickly thanks to the advent of the UAVs with high resolution specialty and spectral cameras. In order to map the distribution of SOC in an agricultural area impacted by erosion. Nonetheless, there are a variety of study methodology in this field, such as those that use the neural networks and predictive algorithms. Conclusion: the most recent advancements in drone technology for precision farming are presented in this study article. Crop monitoring and pesticide spraying are two primary drone applications in precision agriculture data covered in this paper. Specifically, the evolution of drone construction and sensors for data collecting drones that supply pesticides, deep learning, and artificial intelligence in remote agriculture monitoring have all been covered. After 2017, it was determined the use of drones for precision agriculture increased. This is a result of UAVs' decreased weight, increased payload capacity, and decreased cost. Multicopter and fixed wing drones are the most common varieties utilized for livestock detection and crop health monitoring. Because of the large payload capacity, unmanned helicopters are primarily utilized for spraying fertilizers or pesticides. Weight, size, and resolution of drone cameras have all changed significantly. Drone controllers have been upgraded from simple microcontrollers to Arduino Uno and Raspberry Pi with AI capabilities thanks to the development in embedded systems. A farmer-friendly system has been made possible by the incorporation of the machine learning into drones. To boost drone adoption, a number of problems pertaining to the use of the drone technology in the agriculture industry still need to be fixed. The primary obstacles include the high cost of technology, drones' short battery life, visual impairment, and users' lack of technological knowledge and deficiencies in picture processing and data analysis. That's it.